All right, let's dive right into this essential explainer. Today, we are literally building your investigator's toolkit for behavioral measurement. If you've ever felt totally overwhelmed by all the different ways to track and analyze behavior, well, you are absolutely in the right place. We're going to take all those intimidating terms, frequency, latency, interval recording, and make them super practical. By the end of this explainer, you're not just going to have definitions memorized. You'll know exactly how to use them to actually change lives.
We've got a really straightforward roadmap today. We're covering why we need data, the continuous measurement toolkit, sampling with discontinuous measurement, visualizing change with graphs, and then we'll wrap up with an interactive knowledge check to lock it all in. Let's get to it. Section 1, why we need data. Let's lay down the foundation real quick. Why do we even go through all this effort to measure things in the first place? Well, this core rule is pretty much everything in applied behavior analysis, and honestly, any scientific field. We cannot just rely on feelings. You can't just walk into a meeting and say, hey, I kind of feel like the behavior got better. Nope, we need cold, hard data. Data is our only true evidence. It tells us exactly how often a behavior happened, how long it lasted, and most importantly, if our intervention is actually working. Because without data, we are literally just guessing. Section 2. The Continuous Measurement Toolkit. Let's open up that first toolkit. Continuous measurement is where we try to capture every single instance of a behavior. It's the whole shebang, the absolute most complete way to record data. Okay, so for these foundational continuous measures, I've got some great little memory tricks for you. First up is frequency. Just chant to yourself. Frequency equals how many? It's literally just a count. If a child hits 7 times, the frequency is 7. Simple, right? But frequency alone can actually be kind of misleading. Like if a behavior opens 10 times in 1 hour on Monday, but 10 times over 5 hours on Tuesday, well, Monday was way more intense. And that is exactly why we use rate. Rate is just frequency divided by time. Your memory trick here, rate equals how many per time. And finally, duration. You use this when the length of the behavior is the main thing that matters, like a tantrum. Your trick, duration equals how long. We also have percentage in this continuous toolkit. Whenever you're measuring percentage, just think out of 100. We use this all the time for accuracy. Say a kid answers 8 out of 10 questions correctly. We just divide the part, which is 8, by the whole, 10, then multiply by 100. Boom, a beautiful 80%. It instantly tells us the success rate out of the total opportunities. Okay, listen closely to this one because it is a massive exam trap. Seriously, it trips people up all the time. We have 2 measures that involve weighting: latency and inter-response time, or IRT. Latency is the time from the instruction to the very start of the behavior. Imagine you say, touch your head, and the child waits 3 seconds before doing it. That's 3-second wait. That's your latency. IRT, on the other hand, is the time strictly between 2 behaviors. If a child screams, stops, and then exactly 5 minutes later screams again, that 5-minute gap is the IRT. So remember, latency starts with a prompt. IRT happens strictly between behaviors. Section 3, sampling with discontinuous measurement. Moving right along, let's face reality for a second. Sometimes you're in a busy classroom and continuous recording is just impossible. You can't possibly capture every single behavior when you're managing 20 kids. So we bust out our discontinuous measurement toolkit to record just a sample of what's going on. And here is another huge exam trap to watch out for. With discontinuous measurement, we break our observation down into short intervals, like 10 seconds. In partial interval recording, if the behavior happens at any point during those 10 seconds, even for just one tiny second, you mark yes. Because of that, partial interval is always going to overestimate behavior. On the flip side, whole interval means the behavior has to happen for the entire 10 seconds to count. If it happens for 9 seconds, you mark no. So whole interval actually underestimates behavior. So how do we know which tool to use? Well, because partial interval overestimates, you want to use it for behaviors you're trying to decrease, like disruptive talking. Since whole interval underestimates, it forces you to be strict, so use it for behaviors you want to increase, like staying on task. And then we have our third option, momentary time sampling. This is your go-to when you're running a whole room. You set a timer for, say, 5 minutes. When it beeps, you just look up and check the behavior at that exact precise moment. On task at the beep? Yes. If not, no. It's incredibly practical. Section 4, visualizing change with graphs. So the big takeaway here is that once we collect all this amazing data, numbers on a page just aren't enough. We have to map it visually so we can actually see the story, see the behavior change. Let's break down how to make these graphs crystal clear. The absolute simplest memory trick for graphs: The x-axis is the flat line running across the bottom. It always moves across time. Think days, sessions, weeks. The y-axis stands tall on the side, and that shows you exactly what you measured, like your rate, duration, or percentage. Let's see how this actually builds a story. Every number we collect becomes a data point. If we measured 5 tantrums on Monday, 4 on Tuesday, and 2 on Wednesday, we plot those points. And suddenly, we don't just have a boring list of numbers. We can clearly see a decreasing trend. The intervention is working, and the graph proves it instantly. It's like a visual mic drop. To really analyze that story, you need these key terms. We use a phase change line. That's a vertical line right on the graph to mark exactly when we started a new intervention. Then we look at the trend. Is the overall direction heading up or down? We check the level. What's the average height? Did we go from high aggression down to low aggression? And finally, variability. How stable is it? Is it super consistent, or is the data bouncing around wildly? Section 5. Interactive Knowledge Check. All right, it's time to put your brand new toolkits to the test. We're going to do a rapid-fire sequence using actual practice questions. Play along, shout out the answer, or pause the explainer if you need a second to think. Let's go. Read it carefully. Look for those keywords. Are you timing it, or are you counting it? Lock in your answer. If you guessed frequency, you absolutely nailed it. Remember our chant? Frequency equals how many times? We just counted the screams. Notice they didn't ask for screams per hour. That would be rate. It was just the simple count. Think back to that big trap we talked about. You gave an instruction, and there was a waiting period before the behavior actually started. What was that called? Awesome job if you remembered latency. You perfectly separated it from IRT. Latency is always about that pause between the instruction and the initiation of the response. Picture that busy teacher, 20 kids, just waiting for the timer to beep. Which discontinuous method is this? Boom! Momentary time sampling. That's the correct answer, because the teacher is only checking at that exact, precise moment the timer goes off, totally ignoring what happened during the rest of those 5 minutes. You guys have done incredible work today. You are fully equipped to dodge those exam traps. You totally understand continuous and discontinuous sampling, and you know exactly how to map it all visually. But here is the real question. How will you use these exact tools tomorrow to change someone's life for the better? Remember, we don't just say it got better, we prove it. Thank you so much for diving into this explainer with me, and I seriously cannot wait to see the amazing data you collect out there.